The type 2 improper integrals are the ones where you have vertical asymptote between a and b. And the book splits it up into three different cases. One is where the asymptote actually occurs at b. And so for that one, you just take the original integral and you replace b with t, and you take the limit of this as t goes to b from the left. The other one says if it's discontinuous at a, then you basically do the same thing, but you replace a with t and you approach from the right. What's with all this left and right business? Well, if let's say this is your a and your function looks like this, then you're finding the area underneath here, but you're approaching a from the right. So that's the reason you've got the plus there. And the analogous thing happens in the other direction. And if you have something where you have a discontinuity in the middle, then what it says to do is split it up here in the middle. Call the place where the discontinuity is, call that C. And then just break this into two integrals. One with C on top, one with C on bottom. So one gets you this area, one gets you this area. And you just add them together. Of course, both of these things are now, well, one of them is this type and one's that type. So let's do an example. First up, let's look at this. 1 over x squared from 0 to 1. Let's look at that and see what we get. All right. Now, if we follow along with this strictly, we would write the limit to begin with. And that's probably a good idea to do on these. So I'm going to rewrite this one as the limit. Now, where's this thing discontinuous? It's discontinuous at 0 because 1 over x squared, you plug in 0, you've got an asymptote at 0. So you take the limit as x goes to 0 from the plus side of integral, I'm sorry, that shouldn't be an x, that should be a t. So we've got from t to 1 over x squared dx. All right, so t goes to 0 from the right side. Now if you integrate 1 over x squared, that's x to the minus 2. When you integrate that, you get x to the minus 1 over negative 1, or minus 1 over x. So this is going to be negative 1 over x, and we're going from t to 1. Erase the scratch work below. So let's see, we get limit as t goes to 0 from the plus side of minus 1 over x. But let's go ahead and plug the numbers in. Minus 1 over 1 minus negative 1 over t. All right, what do we get there? This becomes this is just negative 1, but this guy we get 1 over 0. So this is this limit does not exist. If we wanted to be technical about it, we would say it's it diverges to infinity. Well, no, this would go to negative infinity, and then so essentially what we've got here is negative 1 plus infinity. So this is an infinite area. So therefore we'd say this integral diverges. All right, so that diverges to infinity. Let's look at the next one. This next one, we've got integral from 5 to 9 of 1 over x minus 5. Now, why is this one divergent? Or, I'm sorry, we don't know that it's divergent. Why is it improper? It's improper because if you plug in the 5 here, you get 0 in the denominator. So let's work this one out. It's going to be the limit as t goes to 5 on the plus side of integral from t to 9 of 1 over square root of x minus 5 dx. How do we do this? Well, we could do it as a u substitution. U is x minus 5. Du then is going to be just dx. Actually, I want to leave my endpoints off for right now because those endpoints are x values. And we're going to have to change them to u values. So what do we get here? This becomes 1 over the square root of u, or u to the minus 1/2 du. And my endpoints on top, let's see, we get the u is going to be 9 minus 5, which is 4. And on the bottom, my endpoint is going to be u equals t minus 5. And we just have to leave it that as t minus 5. So we got the limit as t goes to 5 from the plus side. Left that off up there. When I integrate this, I get u to the positive 1/2 with the, and then you have to divide by 1/2 from t minus 5 to 4. All right, so if I plug this stuff in, I get 2 times the square root of 4 plus 2 times the square root of t minus 5. All right, so 2 times the square root of 4, that's 2 times 2 is 4. And if you plug in the 5 for here, you get 0. So I just get 4 for my answer. So let's check this on Desmos. All right, let's see, that's a little too small to see. I guess I'll go to the big Desmos screen. All right, so let's put this in. Integral from 5 to 9 of 1 over square root of x minus 5 dx. And it gives me 3.999, etc. So that's that verifies that our answer of 4 is correct. Now this is a little bit off because Desmos is doing this with numerical integration. Sometimes you even run into trouble with this. Sometimes you might have to change this, because if you plug the 5 in directly, plugging in that 5 would give you a 0 in the denominator. Sometimes if Desmos gives you an undefined on something like this, you might need to change your endpoint very slightly. Like find the area, instead of from 5 to 9, find the area from just barely above 5. And see what that looks like. But that's a good confirmation that we are correct here. You know what? Let's go back and do the previous one as well. 1 over x squared from 0 to 1. Integral from 0 to 1 of 1 over x squared dx. Yeah, this is one where Desmos says undefined. And I guess that does make sense because this one was infinite. But if you put in something very close to 0, notice it gives you a huge number. And if we make this get closer and closer to 0, notice it's growing to infinity. And if we put in 0 just right off the bat, it tells us it's undefined.